Alright, we're solving equations using log laws. So in this particular problem, you'll see law number 3 of log laws. When there's a number placed out in front of the word log, it gets moved back and becomes the exponent of whatever's in this location. So that 2 will be moved back to here, and we need to then square 3 minus x. So using your FOIL skills, taking 3 minus x and squaring it, you would end up with 9 minus 6x plus x squared, which, use parentheses just in case. Now, these two can be combined using law number 1. When you have two log statements that are separated with the same base, these two locations can be multiplied together to become one log statement. That 2 you could either leave out front or distribute. I'm going to distribute it and rearrange the order. So I'm going to write the x squared times the 2 first, minus 12x second, and the minus 18 third. So law number 3 was first, law number 1 was second. I haven't even touched the right side. I'll bring it down now. On this particular problem, you need to notice that both sides have single logs. There's a log 3 here, and there's a log 3 here. Since both sides have log 3, and there's single logs on both sides, we can drop them. So now, it's a matter of setting 2x squared minus 12x plus 18 equal to the 6 minus x. This just becomes a polynomial equation which you can use your algebra skills to solve. Bring the x over, bring the 6 over, set it equal to 0, and factor. So we get x equals 3 over 2 and x equals 4. Now what you need to do is this. You take your solutions and you check to see if any of them provide an illegal solution. Meaning, this location next to the log can never be 0 or negative. So always use the original equation. That includes when the 2 was located out front. Take your answers, like the 4, place it here. 6 minus 4 is 2. That's a positive number, that's okay to have. Check the 4 here. 3 minus 4 is negative 1. Negative 1 cannot be in this location next to the log, therefore we eliminate it as a possible solution. 3 over 2, placed right here, would give us 1.5, which is great. 3 over 2 here would give us 4.5, which is great. So 3 over 2 becomes the only solution on this problem. Alright, problem B. We move the 2 to the exponent of this location. Now, be careful. When you move the 2 to the exponent of the 4x, it becomes the exponent of both, meaning you must square the 4x. When you square 4x, you get 16x squared. Very commonly missed. Also, log base 5, you'll notice is a different base than this side. So, time to be suspicious. This is just a disguised number. 5 to the what power is 125. Once you recognize that that's just 3, you replace this whole thing with the number 3. Law number 2, which we haven't touched on yet, says that when two log statements with the same base are connected with subtraction, then these two locations can be combined into one log statement using division. So the 16x squared I'll put on top of the 6 minus x. At this point, since both sides don't have the log 2 like they did on the previous problem, we must take this logarithm form and write it in exponent form. Exponent form would be, here's your base, 2, here's your exponent, 3, and this is what it's equal to. 16x squared over 6 minus x. Now we must algebraically solve this. Changing 2 to the third to 8, I'm going to multiply both sides by the 6 minus x, which will give me 48 minus 8x. And now, factor. So we got to 3 over 2 and negative 2. And now you must check back into the original equation. If we start with a negative 2 and we place negative 2 here, this location becomes negative 8. Negative 8 is bad, so we eliminate it as a possible solution. 3 over 2 here is fine, 3 over 2 here is fine, and that means 3 over 2 is the only solution. Okay, I'm going to put up the second problem for you to work on. At this point, you need to press pause, copy these two problems down, and press pause if you haven't done so already. Here is the solution. Press pause if you need more time on that. Otherwise, I'm going to show problem number 3. It's here. Okay. Press pause if you need more time. I'm going to show the solution. And here is the solution to the third problem. Great.